Hello, this is Ms. DB. In this video, we're going to look at how to do a few of the problems from the Chapter 9, Section 5 worksheet, which is on how the area and perimeter will change when you change one dimension of the figure or all the dimensions of the figure. It matters how many dimensions are being changed. For example, in these first problems, they're only going to be changing one dimension. In number 1, they are going to take the base of the parallelogram and multiply just the base by 3/4. So the base is 16, the height is 12. They're only going to multiply the base times 16, not the height. So then you go ahead and you find the area of the original, which is just base times height. Then you figure out what is 3/4 times 16. Use your calculator. And then find the new area. So what you need to do next then is take the new area divided by the original area to write this as a ratio to know how what the effect that changing one dimension has had. Let's do number 3. Okay, so these 1, 2, 3, and 4 are all the same. So for each one, you're going to find the area of the original, change one of the dimensions by however they tell you, find the area of the new, and then write that as a ratio. The area of the new over the area of the original, and then simplify. So in number 3, the height of the triangle is given as 3. Now we could find that, if it wasn't already marked, by just using, this is the height of the triangle right here, and that's 1, 2, 3 units. The length of base, CB, is 1, 2. So the length of the base is 2. The area of the original triangle then is found by using the formula 1/2 base times height. So 1/2 of the base times the height. And when you calculate that out, you're going to get that the area is equal to 3, because 1/2 of 2 is 1, 1 times 3 is 3. Now it tells us to double that base. So picture that would be, instead of 2, it would be 4. The height is going to stay the same. So our area of our new triangle is still 1/2 base times height, but this time our base is 4. The height remains the same as what it was in the original. So we have 1/2 of 2 is 2. 2 times 3 is 6. How did the area change? It went from 3 to 6. If you can't quite see, and this one's easy to see, but we can write it as a ratio as the new over the original. 6 is the new over the original area of 3 equals 2. The area changed by multiplying by 2, or by doubling, or a factor of 2. That's how you'll do 1 through 4. When you change one dimension, the area changes by the same amount. All right, what if you change both dimensions? For example, what if you change both the base and the height? So in this one, they're tripling both of the base of 4 and the height of 3. The original area was 20. The new area is 180. 180, the new, over this, is equal to 18 over 2 is 9. It's 9 times the amount. So it's not equal to the amount that one side changed. It's equal to that squared. So in these first problems, the way that the area changes is equal to how you changed one side. If we doubled one side, the area doubles. But if you multiply all the dimensions of a figure by a number, then the area will be that amount squared. So 3 squared is how the area will change. And that's what this says here. If you are going to multiply all dimensions by a, the perimeter, and we didn't look at this yet, but that will just change by a factor of a. The area will change by a factor of a squared. And here's an example, another example with a rectangle, and you can see that that's going to be true. So on the next problems, you're going to describe the effect of each change on the perimeter or circumference and on the area. So for each one, you have to describe both ways that it's changed. So there's a table to help you do that. Let's look at number 7. The length and width of the rectangle are multiplied by 4/3. So we're going to multiply both of them by 4/3. So we can find the perimeter of the original. 3 plus 9 plus 3 plus 9 is 24 for the original perimeter. And the original area is just 9 times 3 is 27. Now the new figure is we would multiply all sides by 4/3, which is bigger than 1, so we're going to get a bigger rectangle. So we are going to take 3 times 4/3, and that's equal to 4. And we're going to take 9 by 4/3, and that is equal to 12. So now we have a rectangle that is 4 by 12, and 4 and 12, so that would be 16 plus 16 is 32 for our new perimeter, and our area would be 48. Now to find the change, you take the new divided by, or over the old, you write a ratio. So the perimeter changed by 32 over 24, and now simplify this. 32 and 24 are both divisible by 8. I can divide both of them by 8. 32 divided by 8 is 4. 24 divided by 8 is 3. The perimeter changed by the same amount that the dimensions changed. What about the area? The new area is 48. And the original area was 27. Let's see if we can simplify these. Let's see. I think 3 goes into both of those. Let's see. 48 divided by 3 is 16. And 27 divided by 3 is 9. So the change in area is 16/9, which is equal to 4/3 squared. So it's the square of how the dimensions changed. So that's the shortcut right there. This right here is the shortcut. Once you've done a couple of these, then you should be able to do the rest by just using this information right here. When all dimensions of a figure are changed proportionally, the perimeter will change by that factor, the area will change by that factor squared. So do a few of them showing your work, and then after that you can skip to just describing the change of each, the perimeter and the area. Now when you do the circle, it says that the radius with the center at 2, 2 that passes through 0, 2 is divided by 2. So this radius is going to be divided by 2. That's the only dimension you need to find perimeter or circumference of a circle. So that's everything. Everything is being changed by that amount. So when you find your perimeter area of the original and the new, you'll see how that changes. And then, or you can just jump right to describing the change in circumference and area. So remember that the area does not change in an amount equal to how the dimensions are changed, if all the important dimensions are changed in the figure. There's a couple challenge questions that you can also do for extra credit. I highly recommend sketching these and actually finding the area of the original and the new after that change, and then finding out how you would answer that question. All right, so let me know if you have any questions, and don't forget that the area will be the square of how the dimensions have changed for numbers, was it 5 through 10? So it's not equal to the area will not be increased by 6. The perimeter will be increased by 6, but not the area. All right, thanks a lot and have a wonderful day.